on lesson 23. Today we're learning about lines, segments, rays, and angles. On Power Up K, what you're going to do is you're going to go ahead and circle multiples of 9. Then, lucky you, thanks for watching the video. On the bottom here today, go ahead and cross out mental math. Go ahead and just put a big, there we go. Just go ahead and cross out mental math. Don't need to do that. Problem solving, go ahead and just put a big, huge smiley face there. Yeah, that's it. We're not going to do it at the bottom today. So you're just going to go ahead and do the top where you're circling multiples of 9. All right? Press pause, circle all those multiples, and then we'll correct it together. Excellent. If you're listening, you should have completed the circling the multiples of 9. Now, when we count by 9s, we go 9, 18, 27, 36, 45. Now, why is this pattern happening? Well, let's say we started at 9. If we added 10 more, 10 plus 9, we'd get 19. Well, so we'd go straight down in our chart. Well, we're only adding 9, so it's going to be the number right before that. So plus 10, minus 1, plus 10, minus 1, plus 10, minus 1, plus 10, minus 1, 54, plus 10 minus 1, 63, plus 10 minus 1, 72, plus 10 minus 1, 81, and then plus 10 minus 1 isn't actually here, it's way back over here. Plus 10 gives us 91, minus 1 brings us back to 90. Add 9 one more time, and we get 99. All right? Now, as you saw, we're going to cross out this. Just write a big old smiley face for our problem of the day, and then turn it on over. Today, we've got some different types of angles. I'm going to line, segments, rays, and angles. I'm going to stay under my dot cam today because I want you to be able to see what I'm drawing under all these different parts. All right, our objectives today. Today we'll learn how to identify lines, segments, and rays, how to identify perpendicular lines, and how to identify angles as right, acute, or obtuse. Now, in your book, example 1 says, write line, segment, or ray to describe each of these physical models. Before we do it, we need to learn what those all are. Now, for a line, what I want you to draw is draw a straight line. When we talk about lines, we're going to talk about straight things. We're not going to have a whole bunch of curves. Now, a line goes on forever. So write 2 endpoints right there. So a line doesn't have a stop or a beginning. That's a line. Next, let's draw a line segment. Now, a line segment is just part of a line. So you can draw your straight line again. Now, this time you're going to put endpoints here. Now, to one of them, draw a little arrow and write endpoint. Right? This is the endpoint of our line. The endpoint is where it stops and where it begins. Our line has arrows, and then a line segment is just part of that line. Then we've got a ray. A ray is kind of a mix of the two. At one side, we're going to have an endpoint, and at the other side, we're going to have an arrow. Now, rays are going to be what makes up our angles in a little bit farther down on our paper. Right? So line, 2 arrows. Segment, it's got endpoints. And then ray, endpoint here, and then it goes with a arrow on this side. So it starts here, and it's going to keep going in this direction forever. So let's think about this. A beam of starlight. A beam of starlight, what is that? So think about a star. Where does the light start? Does it just never start and never end? Does it start somewhere and stop somewhere? Or does it start somewhere and then just keep on going? Well, it'll start somewhere and then keep on going. So it's a ray. So you'd write a ray for letter A. Then example B, it says, what about a ruler? You're talking about a ruler. Does it have a starting point and an ending point? Yeah, a ruler, you could say this is 0 inches and this is 12 inches or something like that. So it's a segment. All right, so we've learned about a line, we've learned about a segment, and we learned about a ray. A line, 2 endpoints that are going to keep going forever. A segment, 2 arrows that are going to keep going forever. A segment has our 2 endpoints, and then our ray has 1 endpoint and 1 arrow that's going to keep on going forever. Now, sometimes we have lines that we're going to have 2 right next to each other. When they intersect, this is a line, so we should have arrows on both sides. That means they cross. Right? So these arrows, these lines, they intersect because they hit right here. These are intersecting lines. Now, if they don't intersect, go ahead and make yourself a new little spot here. If they don't intersect, they're going to keep going on and on forever without touching. That's what we call parallel. So these ones are parallel. All right, parallel lines. Now, a special type of an intersecting line is a perpendicular line. Now, a perpendicular line meets in what we're going to call a right angle. That means this angle right here is like the perfect corner of a piece of paper. When we say that this is a right angle, we're going to put just this tiny little box there. That means it's going to be a right angle. Okay, so these are perpendicular lines. Now, an angle is where we have 2 rays or 2 segments, and they're going to meet. And we've got 2 sides, and then we've got a vertex. So right here, this is going to be the side. This is going to be the side. And then draw a little end point right here. And a little arrow. This is the vertex. All right, so we had our 2 sides, and then we have our vertex. Man, thanks for taking such great notes with me. That's why I crossed out the front of our power up. Power up. I knew you were going to have lots of notes on the back. Now, for angles, we've got special types. A right angle is just like this one in our perpendicular lines. So a right angle, go ahead and draw one like this. A right angle means that a perfect corner could fit in here. So, let's say I just had this blue sheet of paper. Notice how my corner is going to fit right in that angle. It matches up perfectly. That's a right angle. Now, an acute angle is going to be smaller than that. I always like to think just a cute little angle. Right? Just a cute little angle. It's tiny. If I were to put my blue sheet of paper back in there, notice it doesn't fit. Right? I can't make it fit because that angle is too small. So acute is smaller than a right angle. Then we have our obtuse angle. Our obtuse angle is big. When I think of obtuse, I like to say obtuse. That helps me think that it's really, really huge. It's a huge angle. If I put my corner in an obtuse angle, notice it's bigger than my right angle. It's bigger because it comes out here and then comes out this way, and it's bigger than a right angle. It's obtuse. And that is our last type of angle. All right? So we've got acute little angles, we've got obtuse angles, and then we have our right angles that are just like the corner of a piece of paper. Let's go ahead and look at example 2 in our book. If you need this still, go ahead and pause the video right here so that you make sure your sheet looks like mine. Now, example 2 in our book says describe each of these angles. This one. Notice that it's smaller than that right angle. If I put my corner in right there, it would be smaller than it, so it's acute. It's just a cute little angle. B is a right angle, because see, my piece of paper could fit perfectly in that corner. And then C, I've got this obtuse angle, right? It's bigger than that corner of that paper. We could also look at this quadrilateral and figure out if they're right, obtuse, or acute. Notice T and S, they're both right angles. T, this could fit right there. S, that's a perfect corner. So we got to identify R and Q. R, well, R's obtuse. Notice how it's bigger than this sheet of paper. And Q, well, Q's acute. Notice it's smaller than the corner of this sheet of paper. You do not need to be writing these examples down anywhere. There's nowhere on your sheet for you to do this. All right, let's go ahead and look at our lesson practice. First part of our lesson practice says draw two segments that intersect, but they're not perpendicular. So that would be like this, right? These are not perpendicular. There's nowhere that I could put this corner and it would fit perfectly. That's too big, that's too small. So do something similar for our lesson practice A. Said line, so make sure you've got points or arrows at the sides. B then says draw two lines that are perpendicular. I'm going to draw one horizontal and one vertical. Notice I got arrows on the ends of all those. C says draw a ray. Oh, what's a ray again? What's a ray again? Oh, that's right. One endpoint, and it's going to keep going on forever and ever. So endpoint, and it's going to keep going on that way. D said, are the rails of a train track parallel or perpendicular? Think about a train. Right, a train track goes like this. And the rails are this right here, this top and the bottom. Right? Those rails, are they parallel or perpendicular? Well, they go on and on forever, and they do not touch, so they are parallel. Excellent. Then for E, it says a triangle has how many angles? Draw a triangle. How many angles? 1, 2, 3, right? 3 angles. However many sides something has, that's how many angles it's going to have as well. So a triangle has 3 sides, so it's also going to have 3 angles. F, let's look at our angles. Which of these angles does not look like a right angle? I'm just going to take the piece of paper right here and try to fit this in the corner. A. Oh, yep, that fits perfectly. B. That's too small. Let's just verify. C. Yep, fits there. And D. Yep, fits there. So it's got to be B. So for F, I'm just going to write B. Excellent. Thanks for working so hard on your notes. Let's go ahead and rock it out on a couple of our problems for today. We are on lesson 23. Double check that you got your name at the top. Page 144 and 100 through 146, and let's start with number 7. Number 7 says round 92 to the nearest 10. Remember, 0 through 4 don't get no more. 5 through 9 go up 1 time. So if we're going to round 92 to the nearest 10, I underline my 9. 9 is going to look at the 2. The 2 says, well, is it 0 through 4 or 5 through 9? 0 through 4 don't get no more. 0, 1, 2. Oh, it's between 0 and 4. So it don't get no more. So this stays at a 0 and this stays at a 9. So we get 90. Next one, $19.67. Round it to the nearest dollar. So I'm going to underline my 9, look across the decimal point at the 6. 6 says 5 through 9 go up 1 time. So my 19 is going to go up to $20. So over at the side, that would look like A, 90, B, $20. Number 8. The radius of a nickel is 1 centimeter. If 10 nickels are placed in one row, how long will the row be? So the radius of a nickel is 1 centimeter. So draw your nickel. Radius means from the middle to the side is 1 centimeter. Well, how far across is the entire thing then? Well, 1 plus 1 would be the diameter is 2 centimeters. Now, this isn't just 1 nickel that we had put there. We said 10 nickels. 2 centimeters, well, if we had that 10 times, 10 times, well, 2 times 10 is 20, so it would be 20 centimeters long. Number 9, use a centimeter ruler to measure this rectangle. What's the length, what's the width, and what's the perimeter? So length, width, perimeter. Let's look at the length first. The length is the long side. So the length, start at 0, come across. We're at 3 centimeters. And the width, that's 1 centimeter, 0 to 1 centimeter. And then remember, perimeter is the distance around. So I got to do 3 plus 1 plus 3 plus 1. 3 plus 1 plus 3 plus 1. 3 plus 1 is 4, plus 3 more is 7, plus 1 more is 8, so I get 8 centimeters. So A, 3 centimeters, B, 1 centimeter, C, 8 centimeters. Go ahead and flip it over. Next, we'll take number 20. Number 20 says K minus 22 equals 22. Well, I've got a missing number and a subtraction sentence. The missing number is first, so I add 22 plus 22. 2 plus 2 is 4. So we get 44 as our answer. $25. How many nickels equal $1? Well, if you count by fives, how many fives are in 100? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Well, there's 10 in 50. So 10 and another 50. So there's 20 in $1. So there's 20 nickels in $1. So a nickel is what fraction of a dollar? 1 out of those 20. Oh, this should be C. And then 7 nickels are what fraction of a dollar? Well, that would be 7/20ths. So A, 20, B, 1/20th, C, 7/20ths. And then 27, which of these figures illustrates a ray? Remember, an array has one endpoint and one arrow. That would be C then. One endpoint and one arrow. Because remember, array looks like this. All right, so C. Excellent. Good luck on the rest of your work today. Make sure you reach out if you got any questions.